All right, so yesterday we talked about how we can find the volume of an object by first identifying the shaded region, looking to see where the axis of revolution is, and then identifying the radius, and essentially radius because we're rotating that two-dimensional region around an axis, and it's going to create some sort of a bowl or some sort of a circular cross-section shape. We don't have to worry about what that shape looks like. We just have to be able to know how to gather enough information to put it into a volume formula to find the volume of that object. So today we're just going to practice between top minus bottom and right minus left, and also looking to see why something is this method versus what we're going to see tomorrow with washer method. So number one says, let the region R be the area enclosed by the function y equals 2x cubed. So this is 2x cubed. That's going to be the cubic function here. The horizontal line y equals 8. That's over here. And the y-axis, which is here. So with those three boundaries in place, we can say for certain that the shader region that we're talking about is this region here. That's right. Dotted line will be y equals 8 because we're rotating about this line. So this is the new center of my object. I'm not drawing the full object here, but we understand that this object will get flipped over on this side and it's going to start rotating and it's going to create some sort of a bowl object. All right, so do we see that there's a flat surface up against the dotted line? There's no gaps. So there's no gaps. All we need is one radius. So the radius, because the axis is horizontal, that means my radius will be what? Also will be perpendicular, so will be up and down. Right? So we never have to guess how to draw our radius. Our radius is always going to be 90 degrees and always connected to your axis of revolution. Okay. So you're always going to start on your axis and you're going to extend to the boundary of your shaded region. So this is going to represent my radius. All right. Let's build our radius. So big R equals, okay, top minus bottom. Let's look at the top of the radius minus the bottom of the radius. So what's the top of the radius touching or sitting on? 8. So 8 comes first. Minus, it's always going to be top minus bottom here. What's the bottom of my radius sitting on? What? 2x cubed, right? Okay, so we pretty much have what we need for this method. But what do you think x1 and x2 will be? X1 will be what? What's the furthest left of my shaded region? X equals 0. What's the furthest right? Okay. Wherever that, what? Intersection. So how can I find that intersection? Set them equal. So I can either do this by hand, or I can make the calculator find the intersection for me. So I'm going to do this by hand. I think it's easy enough for us to algebraically do it. So 2x cubed equals to 8. How would you solve for x from here? Okay, divide by 2. So 8 divided by 2 is 4. And then we can take the what? Cube root. So cube root of 4 is just going to be some decimal value. You can leave it like that, or you can have it as a decimal value. which is around 1.587. But I think cube root of 4 is probably, it's more accurate because then you don't have to worry about decimals. The way you get to cube root is you do math 4. Math 4 will get that cube root to show up. Okay, so I think we have everything that we need to build our volume formula. So V equals pi, definite integral from 0 to cube root of 4. Big R squared. Let's make the calculator do the work for us here. So under y1, I'm going to call this 8 minus 2x cubed. Second mode, I'm going to go back to my home screen. Leave pi out of your calculator. I was just going to go from 0 to cube root of 4. Cube root of 4 is math 4. Math 4 will get that cube root notation to show up. And I mean, you can type everything in the same line. It's just that then you got to use a bunch of parentheses and you got to keep track of all that. And I think it's just easier to just let y1 hold my radius. And that way I can just do alpha trace y1 and just square it. It looks very clean. There's no need to worry about parentheses because y1 is holding my entire radius. Dx. Looks like it's not able to convert. Well, okay. Sometimes it's able to convert to a really messy fraction, but you know, if that's the case, I'm okay if you just leave it with 3 decimal places, and that's fine. Okay.
How do you convert to a fraction?
You do math 1. But that feels even more complicated, so we can do decimals. But if we do decimals here, we gotta, well, we gotta still include what as part of our volume? Yep. Units cubed.
Some of them can't each convert to.
Right, if it doesn't, then 3 decimal places is good enough. Okay, any questions so far? Okay, let's look at part B. Same shaded region, same equation, same situation. Rotated about the y-axis. Do we see any gaps between the shaded region and the dotted line? No gaps. So this is also this method. I know we haven't talked about the other method yet, but I think it's good to begin to see, okay, this is, I have a flat surface up against the dotted line. There's no gaps. This is going to be this method. What's different about this situation here? How do we draw the radius differently here? It's going to come out horizontally because your radius is always going to be 90 degrees with your axis of revolution. So we never have to guess how our radius is coming out because you're always going to be told what the axis is. And if you know what the axis is, you can, from there, you can build out your radius. But what's the red flag with horizontal radius?
Reverse.
Okay, what else?
Oh,
We got to change the equations, right? The equations are not fit for right minus left. This is the biggest issue that students have. I know as it feels easier. Well, why can't I just use this equation for this curve? Well, everything is rearranged. My orientation is rearranged. My variable has to be adjusted. So that's the biggest roadblock that students have, just for, not knowing or forgetting to rewrite that equation. So this equation, I mean, it is y equals 2x cubed, but we got to rearrange it. So we got to solve for what? X. So y equals 2x cubed. I'll make this 2x cubed equals y. So how can I do things so that eventually I can get able to solve for x? First, I can do what? Divide by 2. And then cube root. So it looks a little messy. And also there's no plus or minus with cube root. So it's just going to be the cube root of y over 2. And that will be representing this parabola here. Or sorry, not parabola, this cubic function here. What's the equation of this line? X equals 0. Notice how both equations are in the appropriate format for my right minus left formula. Okay, let's build our radius. But now it's r of y, not r of x. We'll do right minus left. What's the right endpoint of my radius sitting on? What's it touching? Was it steady? Yeah, cube root, right? Okay, cube root of y over 2. Right? Okay, right minus left. So right minus, what's the left endpoint touching? 0. So that's it. This is how we build the radius length. And then this variable will adjust to the shifting length of the radius depending on where we draw it. Right? But we just need one representative rectangle because ultimately there's infinitely many, but the variable is adjusting to all the change in length as we add those infinitely thin rectangles up. Okay, let's build our volume here. So V equals pi, definite integral from. Now, can I say from 0 to cube root of 4? What will my bounds now be? 0 to 8, good. Sometimes it's easy to tell because in this case, it's just going to be a nice horizontal line. But if it's not the case, then we may have to set equations equal to each other or plug in the calculator, find intersection. But sometimes it's easy, especially if it's just a 0 and a horizontal line. So 0 to 8, those are my lowest and highest y values. We're stacking these circular disks from the lowest y value to the highest y value. This is the orientation of our volume. Big radius squared. So your paper is showing y, but your calculator will show x. So I'm gonna rewrite my y1. I'll do math 4. I'll do alpha y equals to get that nice math print to show up. And I'll do what? Cube root of what in the calculator? X over 2. Yeah. I'm leaving that squared out. I'm just writing my radius, and then I'm saving my squared for now. I can just really reuse what I already typed in before, right? I can still keep that y1 squared. My integral is still there. I can reuse. I can just scroll up and reuse the same setup. I just have to change my upper bound there to 8. Okay, doesn't convert to a nice easy fraction for me, so I can just say 12.095 what? Pi units cubed. Good. Okay, so today I just want us to work on this worksheet, this page and the next. I'll work the problems as you guys try it, and you guys can check your progress with what I'm working up on the board, and whatever we don't finish will be your homework. Okay. All right, so let's see if we can get some practice in. Any questions so far? careful with your radius, top minus bottom. That bottom has multiple terms in it. You need to protect that bottom with a set of parentheses. Otherwise, we may forget to distribute that negative through to both of these terms. I worked out the intersection by hand, but you can also use your calculator, graph both lines, find the intersection, and you'll get a decimal version of natural log of 5, which will also work. Okay, any questions here? Okay.
You know, on the calculator.
Yeah, practice doing that. I would have 5 minus e to the x as my y1, and then just do alpha trace y1 squared.
So ever be a situation where you use like substitution or anything for these problems?
Not on the quiz, but on the AP exam, if it's non-calculator, you may get a problem that has use substitution in it. Yeah.
When is the quiz for this unit?
Not next Friday, but the Friday after. Yeah. We'll have our final topic lesson on Tuesday, and then all the remaining days we'll have review. Okay, go ahead and try next one. Yeah, question. I'm sorry? Oh, right, so your calculator can't.
Wait, why is it 3?
Why is it 3? That's the lowest point, that's the y-intercept of this graph here. So y-intercept is when x is 0, so of this curve. So if I replace x with 0, e to the 0 is 1, 1 plus 2 is 3. And then your calculator can't handle a y, so on paper, you're gonna write down y, but in your calculator, you'll use x instead.
It just keeps saying like error.
Okay, I'll come look at it.
So this is what I prefer to do. I like to just have my one hold all that information. So, okay, yes.
Sorry, I don't work.
So 2 from 3 to 7. And then there's that alpha trace where you can use that to get your y1. Oops. And we square that, there's no new parentheses and then
Oh, yeah. I've been doing 0 to 7, so it wasn't working.
right, because 0 is not part of the shaded region. It's all the way up that. That's the region.
Okay. I recall just even though it's worked.
Yeah, so typically I would say parentheses is not as important for the first expression, but if the expression after the minus sign has multiple terms, then I definitely need a precedence. Otherwise, I'm going to forget to be the negative root.
Yeah, like you do the second thing like e to 0. Like, why'd you do that?
Because I need to find out what is the y value of my lowest point of the shaded region.
Okay.
And that y value is also the y-intercept of my curve. Right? Y-intercept means my x is 0. So I can just plug 0 into my equation to get what my y value is at that point.
Okay.
Yeah.
Well, just in case, right? If the graph is not, because on the quiz, I'm not going to label the, I'll draw the graphs for you, but I won't label all of them. So you have to be able to find it on your own. Okay. Okay, any questions, first page? Okay, let's keep going. Then we still need to look at the first page. Now this is going to be part B is going to be right minus left, which means I need to find the lowest and the highest y value. I can tell my lowest y value is based off that horizontal line y2. Now the highest y value is basically just figuring out what is the y value at this point when x is 2. So if I just plug 2 into my curve, I can figure out what the y value is. So if I plug 2 in for x, 2 cubed is 8, 8 plus 2 is 10. So this point has a y value of 10 because I know if I know the x value of a curve, I can figure out the y value at that point. Oops, I messed up. I didn't do my full radius here. Radius is right minus left. Right endpoint is sitting on the 2. So it's going to be 2 minus the right endpoint minus left. The left endpoint is sitting on the curve that has been rewritten. So cube root of y minus 2. All right, any questions up to this point? Okay, number 4. Yeah.
Oh, I was gonna say, are we ever gonna do like application problems on some of these? Yeah.
No, not really. It's just gonna be pretty straightforward
Alright.
with, yeah, even the free response questions will be kind of like this, where just asking find volume won't be a like a word problem setup. Okay, so we basically finished this worksheet at, in class, so, I'm just gonna check off this as your homework tomorrow as I walk around, between these two pages. And tomorrow we'll start, talking about where there's a gap called washer method. All right, come get your phones.